Hello everyone, welcome to part 3 of my periodic table and matter review video. In this video we're going to talk a little bit about the periodic table, and I'm going to show you how to color in your own periodic table so you have one that's really useful for class. Now the first thing I want to talk about is, well, I got a couple papers here. The first thing I want to talk about is names and symbols, because we're going to start talking about elements and you're going to see the element symbols on the periodic table a lot. Now for element symbols, we always use the first letter is going to be capitalized and the second and third letter are going to be lowercase. It's usually 1 or 2 letters, sometimes 3. And we always capitalize the first letter and lowercase the second one, so we know that it's part of the same element. If you have another capital letter, that's going to be the start of the next element. Chemical formulas show how much of each element we have in a compound. In this one, you'll notice that we use little subscripts that tells us how many atoms of the previous element we have. And you have to make sure you capitalize each element so that you know they're 2 different things. If you hadn't capitalized this O, it would look like CO2, and then that's cobalt, not carbon dioxide. So you gotta make sure you capitalize your letters. Now phases, we're going to talk about phase changes in the periodic table because certain elements are solids, liquids, and gases at different temperatures. So we put a little symbol at the bottom of this, like right here, to show if it's a solid, a liquid, or a gas, or if it's aqueous. So solid has a little S, liquid has a little L, gas has a little G, but aqueous means that it's dissolved in water and we put a little AQ. So let's say I dissolved sugar in water, I would write C6H12O6, and if it's dissolved in water, I'll put a little AQ. So this is sugar dissolved in water. Or if I had liquid gold, so I melted gold, I would write AU for gold, and then a little parenthesis, I'd write an L to show that it's a liquid. Okay? Now, for the periodic table itself, our periodic table is set up very specifically. So we have groups and periods. Groups are the vertical columns on the periodic table. Periods go left to right. And we're going to color code those on our periodic table. Now, groups can also be called families. I usually call them groups, but if you're reading a book, a textbook, and it says families, it means the same thing. And when they're in the same group or the same family, they're going to have similar chemical properties to each other. Now, periods, on the other hand, go side to side. For these, they only have similar properties when they're close together. If they're on opposite sides of the periodic table, they're not going to be similar to each other. Now, on our periodic table in the classroom, our states of matter are color-coded. So the periodic table tells us what state of matter an element is at room temperature. So if it's black, it's a solid. If it's blue, it's a liquid. If it's red, it's a gas. And if it's white, it's unstable. And we're going to color code that on ours. We're not going to worry about the unstable ones on ours, but you can see which ones are unstable on our periodic table in the classroom. Now, there are 3 main types of elements out there: metals, nonmetals, and metalloids. And the main thing that makes them different, and I'm going to put a star next to this because this is really the definition, is how good they are at conducting. So metals are good conductors of heat and electricity. They're very good at holding heat and electricity in. Nonmetals are really bad at holding heat and electricity in. And then they came up with a third group. And this was a group of semiconductors, which means they're medium at holding heat and electricity in. So they picked this group because they're like, well, they're not great. They're not exactly like metals. They're not exactly like nonmetals. So let's make a group that's in the middle. So metals, they're good at conducting heat and electricity. If you think about a car on a hot day, if you touch that metal car, it's going to be very, very, very hot. If you stick a metal fork in an electric socket, you're going to get shocked. Okay? They're malleable, which means we can bend and shape them or flatten them into sheets. They're ductile, which means I can stretch them out into wires. And they have great tensile strength, which means it's hard to rip unless they're very, very, very thin. Think about trying to rip a piece of metal in half, right? It's not going to happen. Nonmetals, we said they're poor conductors. This is why we use nonmetals when we're trying to protect ourselves from heat and electricity. So like an oven mitt has nonmetals in it so you don't get burnt. Wires have rubber around them because rubber is a nonmetal to keep you from getting shocked. Many of them are gases at room temperature, and they tend to be brittle. Brittle means they can break easily, okay? Kind of the opposite of great tensile strength. That means they're really hard to rip apart. Brittle means they're easy to crush into small pieces. Now, metalloids are in the middle. So they're similar to metals and nonmetals. They're in between. All of them are solids at room temperature. Now, they're less malleable as metals, so they're not as good at being bent in shape, and they're less brittle than nonmetals. So it's like they're in between, okay? So if malleable's on one end of the spectrum, that's metals. Brittle's on the other end. Metalloids are in the middle, okay? Now, let's actually get into coloring our periodic table. So let me set this aside. So in class, we colored this in together. If you are out of class, you can color this in now. If you already did this, you already colored it in, you don't need to watch this part of the video. It's just here to help you if you were not here. So the first thing, we're going to use markers for this first part. I want you to use markers when I tell you to and colored pencils when I tell you to. Now the first thing we want to mark is the gases and liquids. Now most of the periodic table is solid, so we're not going to mark those ones. But we're going to mark the gases and the liquids. So the gases, I'm going to put a little red dot in the corner. And the liquids, I'm going to put a little blue dot in the corner. Okay? So for my liquids, I'm going to do those first because there's lots of them. Mercury is a liquid at room temperature, and bromine is a liquid at room temperature. And those are the only two liquids at room temperature. Okay? Now for gases, our first gas is over here. It's the only gas over on this side. And then every other one with a little dot in the corner over here is going to be a gas at room temperature. So when you go to double check, make sure you have, I believe it's 11 red dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so make sure you have those marked before we keep going. Now, if it doesn't have a little dot in the corner, we're saying it's a solid. Now, the next thing we need to do is we need to put a little line around which ones are the nonmetals. And to do that, I'm going to use, I like blue today. So for my nonmetals, I put a dark outline around them so it's a little easier for you guys to see. But we're going to outline them in a marker color so that we know which ones are the nonmetals. So the first nonmetal is actually hydrogen over here. Hydrogen's the only nonmetal on this side of the periodic table, so don't forget about it. Now the rest, we're going to start at carbon, and we're going to kind of draw almost a little staircase shape. I'm going to drop down, go over, and then this whole little corner over here is our nonmetals. Okay, so those are all nonmetals. Our metalloids are shaded in gray. Okay, and our metals, I'm going to outline those in pink, just so I have them outlined. So everything else is a metal. So I'm going to ignore the ones in gray because those are my metalloids. But everything else on this periodic table is a metal. Most of the elements are metals. Okay. And these guys down here are also metals. Okay, and I've got my color coding. I'm not going to outline the metalloids because that's why I shaded them in gray for you guys. Okay, if you want to outline them in your own color, you're more than welcome. Now the next thing we're going to do is we're going to mark up the stuff at the top. Okay, so these are different pieces of information about our elements, and it's going to help us when we're doing some of the work later. So I'm going to start with green. So the first thing I want to mark is the periods. Now periods go from left to right. Now it might seem a little confusing because the numbers go up and down over here, but this one is saying that this is row 1, row 2, row 3, row 4, row 5, all the way down. So to help you remember this, I put up here a little key that periods go side to side. So I'm just going to highlight each of these numbers in green so I can remember that these are my period numbers. Now I'm going to do the same thing for my groups. Now groups go up and down, so the numbers are at the top of each column. So my group number is the number right above the column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so those little numbers right above each column are your group numbers. I need another color, hold on. Okay, orange. Okay, now the next thing we're gonna mark up is the valence electrons. Now we're not gonna worry about what valence electrons are right now, but where you see VE minus, that's where we're gonna highlight in orange, or whatever color you like. So 1 VE minus, 2 VE minus, we skip the middle, there's none there. 3, 4, 5, 6, 7, 8. Okay? And the last thing at the top we need to mark, what color haven't I used yet? Yellow, orange, blue, pink, green. I'll use purple. Okay, is the charge, and we'll talk more about charge as well. So we have +1, +2, we skip the middle again, +3, -3, -2, -1. So all we did, and I'm just gonna very quickly, I'm just gonna bring this down for a second to show you closer, okay? So at the top here, we highlighted each section and we kept the colors the same. Okay, so periods, the period numbers go down the side. So here this would be, for example, period 5 going across here. Groups go up and down, so this is group 1. So now we're gonna switch, let me make sure you guys can still see. We're gonna switch to coloring in each group. Now for this part, I want you to use colored pencils. And if you notice here, you have a key. We wanna make sure we're color coding our key as we go. So our first group, and I'm gonna tell you a little bit about each group as I color. Now I'm not gonna put the notes underneath here because you have them printed out in your notebook. They look something like this, okay? You have a printout version of this. But I'm gonna tell you about each of the groups as I color them in, okay? Let me find a good place to put this so it doesn't get lost. Okay, so our first group is called the alkali metals. It's in group 1. Now it's not hydrogen. We are not coloring in hydrogen here, but everything underneath it. Now I want to make sure you shade it in with colored pencils so that you can still read the numbers underneath because we need all those numbers. If you're coloring so dark you can't see the numbers, then you're doing it wrong. Okay, alkali metals are soft silver metals and they actually explode in water. So we don't find them as pure elements in nature because they're so reactive that they explode even when they're in contact with like water vapor in the air. The next group is alkaline earth metals. They have a similar name. I'm going to use orange for these. And it's the column right next to it. Now these metals have very similar properties to the alkali metals, but they're not as reactive. So they're less reactive, they're harder and denser than the other ones, but they are still silver and but less soft than the alkali metals. Now our next section, I'm going to use yellow. It's the transition metals. Now the transition metals is a big spot. It's called the transition metals because it transitions us from one side of the periodic table to the other. Now for transition metals, this is where a lot of our elements that are metals that we know are. Copper, silver, gold, nickel, titanium, iron, things like that. So it's going to go all the way up. If you notice how this drops down a little bit, it's going to go all the way across. Like that. This whole section is the transition metals. Okay? Transition metals are very good conductors and they have high luster, so they're very shiny. Now, there are some metals that don't really fit into the other groups. We just call them the other metals. And if you look, we have the little staircase from our metalloids. They're the ones below that. So I'm going to color these in light green. You notice I'm not doing a great job coloring, but that's okay. You guys can see what I'm doing. So these other metals, they have the same properties as other metals that we've talked about. If you see your notes from the periodic table notes, you'll see more properties of metals there. But these are just all the metals that didn't fit into another group. Okay? The next group is the metalloids. Now I'm just going to leave them gray, but I'm going to draw a little gray blurb here to help me remember. And we already talked about metalloids at the beginning of the video. Other non-metals, Ledge, don't bark. You're fine. Sorry, my dog sees a critter out the window, so if he barks, I apologize. The next group is the other non-metals. So these are the non-metals that didn't fit into other groups. A lot of these are the ones that you learned about in biology as elements of life. So if you remember CHNOPS from biology class, we have carbon, hydrogen over here. Don't forget about hydrogen over here because it's one of these other nonmetals. Oh, let me make my key. All the way over to oxygen. So carbon, nitrogen, oxygen, fluorine, sulfur, not fluorine, phosphorus, sulfur, and selenium. Okay. Now the next group is our halogens. I'm going to use like a darker blue for these. Okay. Halogens are the most reactive elements on the periodic table, and they tend to form salts when they react with metals. So let me just move this over so I can color easier. Here are my halogens. They are very reactive nonmetals and they form to make salts. Okay, my last column here are my noble gases. Now noble gases are called noble because they don't react with other elements. They just do their own thing, and we'll talk about why that happens later on this year. They're also called the noble gases because they're all gases at room temperature. So this very last column here is our noble gases. Now we have two columns at the bottom. I'm going to use pink for the first one. Our first one is called lanthanides. Okay, and I'm just going to rotate this so I can color it easier for a second. So this top row is the lanthanides. I'm going to color them pink. And then the bottom row, I'm just going to leave as white. So I'm going to draw like a little white spot here to represent that last one I'm just leaving white. Okay, those are the actinides. Now lanthanides and actinides actually aren't just below the periodic table. If you look here, there's a little spot. They actually fit in here. So if I cut my periodic table down here and I shove these in between, that's where they would actually go. If you look at the numbers, it goes 57, 58, 59, 60, all the way up to 71, and then back up to 72. The reason they put them at the bottom is because not a lot of chemists use these elements, and otherwise we'd have a periodic table that was twice as wide. So they said, you know what, let's move these down to the bottom so we can fit it on one sheet of paper. Now, actinides are very reactive. A lot of them are radioactive. Lanthanides tend to be shiny metals, okay? They're very similar to the group 2 metals over here, and some of them are radioactive. Okay, so we see a lot of radioactive elements in this bottom 2 rows. Okay, so that's our periodic table. Now, I want to just show you a couple examples of questions I might ask you using the periodic table. So, for example, I might ask you, let me just flip to a clean piece of paper. Let's see if I have space here. I might ask you, for example, to tell me a group 2 element. Okay, so I might say, tell me an element that is in group 2. So if I look, I know my groups go up and down. So any of these elements in here would work. So I could say BE, for example. Okay, so that's my group 2 element. I might ask you for an element in period, I can't spell today, 4. Okay, so I find period 4, goes side to side, and then I can give you any element from that row. So I'll give you K, because that's the first one. Okay? So we can use our groups and periods to find elements. Now let's make it more specific. What if I asked you for a element in group 3 and period 4? Okay, so we're kind of playing Battleship here, where we have to find the group and the period and meet in the middle. So if I find group 3, 1, 2, 3, and period 4, the one that meets in the middle is scandium. Okay. What if I asked you for an element that is a liquid metal? So now you need to think about 2 different things. So if I look, I know my metals are in this pink area I outlined. If I look, I know this one's a liquid because it has the little blue dot in the corner. So my only liquid metal is mercury. Let's get even more specific. What if I wanted a gas that is not a noble gas? So let's find our noble gases first. So my noble gases, I know they're noble gases because we colored them in purple. Okay? And I know the ones are gases because they have a little red dot. So I can't pick one of these, but I can pick any other gas that I see. So I could pick oxygen, for example. Okay? So I'm going to be asking you questions like this, where you're going to need to use your key to find this information. So let's just go over the key one more time. First, you know what type of element it is, what group it's in, based on the color that you colored it in colored pencil. So if it's red, it's an alkali metal. If it's gray, it's a metalloid. If it's purple, it's a noble gas. Okay? You know if it's a solid, a liquid, or a gas based on the little dots you put in the corner. If it's red, it's a gas. If it's blue, it's a liquid. If there's no dot, it's a solid. Okay? To know if it's a metal, a non-metal, or a metalloid, you want to look at the outlines. So metals, we outline them in pink. Non-metals, we outline them in blue. And metalloids, we didn't outline them at all. And the last thing, groups and periods. The period numbers are here. So for example, if it's period 6, that's this whole row. And if it's group 6, it's this whole column. Okay? So groups are the numbers at the top of each column. Periods are the ones at the side of each. Okay? Thank you guys so much for watching. Let me know if you have any questions or concerns. And that's all I got for today.